Hi, I'm Dr. De Bruin, and this is another A-level chemistry exam question walkthrough from the electrochemistry topic. Let's get started. In the first part of this question, we're given the conventional representation for an electrochemical cell and asked to identify what the electromotive force of that cell would be. So in order to do this, I need to know which one of the equations is proceeding in the forward direction and which is proceeding in the reverse direction. And because they've given me a conventional representation, it's important that I look at that, because it is possible that they would give me a cell that doesn't actually work. So although typically I would look at the values and say, let's take the more negative value and flip it over, I definitely need to double check. So I know that in a conventional representation, the right-hand side is always going in the forward direction and the left-hand side is the one that is being flipped over and is actually going to proceed as an oxidation reaction, not a reduction reaction. So here it's my zinc-based half cell that is proceeding in the forward direction. So I've got minus 0.76, and then my barium-based half cell, that's the one that is going in the reverse direction. So actually the value that I'm playing with is plus 2.90. So I know that zinc is going forwards and barium is going backwards, so I can either do minus 0.76 minus 2.90, or I can change the sign and add it on. Either way will give me the same answer, which is going to be an electromotive force of plus 2.14 volts. You don't actually have to put the plus sign on, but I personally always do, because there's just too much risk that if there's a little mark on your paper, it could look like a minus sign, and a nice big clear plus sign just makes it very obvious to your examiner that you know what you're doing. Then we need to write a half equation for the reaction occurring at the positive electrode of this cell when a current is being drawn. So the positive electrode, that is the one that is not in the process of receiving electrons. So it's positive because it's given up electrons and they've been taken away from it. So we need to think which one of these cells is going to be taking away electrons from the electrode. And of course, in this instance, that's going to be our zinc. It's happening in the forward direction. So my zinc 2+ ion is picking up 2 electrons to make zinc metal. Next up, deduce how the potential difference of this electrochemical cell is going to be affected when the concentration of zinc 2+ is reduced. So if we think about the reaction that's actually happening, we've got barium reacting with zinc 2+ ions to produce barium 2+ and zinc. So if you think about this like a chemical equilibrium, because that's what it is, then if we're reducing the amount of zinc 2+, then we know that the position of equilibrium is going to shift to the left in order to counteract that reduction in the concentration of the zinc 2+. So if the equilibrium is shifting to the left, then the forward reaction that's generating this potential difference is going to be reduced. So the potential difference will decrease because the equilibrium has shifted to the left. Next up, we need to calculate a value for the electromotive force of the cell represented by this one and use it to explain why zinc corrodes when in contact with water containing dissolved oxygen. It's important that if you've been given the conventional representation for a particular cell, then regardless of what the inverted commas right way for the reaction is, we're calculating the value, the electromotive force, in the direction that it's been given. So we remember that the right-hand side of the conventional representation is happening in the forward direction, and it's the left-hand side that's being flipped over. So in this instance, that means we'd be doing minus 0.76 take away plus 0.40, which gives us a value of minus 1.16. Now, of course, the fact that that is a negative value means that that reaction would not happen spontaneously. So when you have zinc put in water that has oxygen dissolved in it, we don't have this reaction where more zinc metal is being made from zinc ions. In fact, the reverse is going to happen. So the reaction is going to go in the opposite direction and therefore break down zinc into zinc 2+ ions. Electrochemical cells can be rechargeable or non-rechargeable, and zinc-silver cells are a common type of rechargeable cell. Why is that? Well, it's because it's a reversible reaction. Thank you very much for watching, and I hope you found going through that exam question with me useful. If you are finding this series useful, then don't forget to like, subscribe, comment to tell me which topics to do next, and also share the channel. And I'll be back soon with some more A-level chemistry.